Hi everyone, welcome back to the channel. Today we're diving into a fascinating topic in software design, the servant pattern. If you've ever wondered about organizing your code in a way that promotes flexibility and ease of testing, the servant pattern might just be the answer. In this vlog we'll explore the basics of the servant pattern, compare it briefly to dependency injection, and then roll up our sleeves to implement a simple Windows system using Rust. But before we jump into the code, make sure to hit that like button, subscribe if you haven't already, and let me know in the comments what your thoughts are on design patterns. Alright, let's get started. First things first, let's understand the servant pattern and how it differs from dependency injection. The servant pattern is all about having a special object, a servant, that assists other objects by providing them with specific functions, reducing redundancy, and making it easier to add new features. On the flip side, dependency injection is about reducing connections between different parts of the code by giving a class the things it needs to work, usually in a predefined form. Now, let's delve into the implementation details using Rust. We're going to create a simple Windows system using the servant pattern. We have two types of windows, rotatable and non-rotatable. Our helper object, the servant, will be responsible for making the rotatable window spin. So we start with the necessary imports and define a rotatable trait. Let's see if we can do that. This trait ensures that our windows can rotate, returning a result in case something goes wrong. We then have two window types, rotatable window and non-rotatable window, both implementing a rotatable trait. But first, build the rotatable window. As you can see, we have a constructor, a new method, an open and a close method, which print out some message. We implement a rotatable trait. This also prints out some message and returns an OK, because we can rotate the window. Next we implement the non-rotatable window. There we go. This is more or less the same implementation, but this time the rotate method in the implementation of the rotatable trait returns an error, as you can see, since it cannot be rotated. Then we come to the heart of the pattern. We introduce the rotation servant trait, specifying a method to rotate a window. The actual servant implementation, the Windows rotator servant, calls the rotate method on a rotatable object. Let's see what that looks like. Again, there's a rotate method which returns a result, but this time it gets a window as one of the parameters and the number of degrees by which the window should be rotated, and it returns a result. And then we implement that trait in the Windows rotator servant, and it simply calls the rotate method on the window provided. Now we can test our setup. We have to remove this, sorry. We set up a rotator servant, a Windows rotator servant, a rotatable window and a non-rotatable window, and we try to rotate it. As expected, you get an error when we try to rotate the non-rotatable window. Let's see if that works. And it works. course I tested this before. In conclusion, the servant pattern proves to be a powerful tool for enhancing your classes with new features without cluttering up their code. It's especially handy when you need to keep different tasks separate, as demonstrated by a rotating window example. What are your thoughts on the servant pattern? Have you used it in your project? Let me know in the comments below. Well, that's it for today's vlog. If you found this video informative, don't forget to give it a thumbs up, subscribe for more content and hit the notification bell to stay updated. Thanks for tuning in, and I'll catch you in the next one.